So can you see the screen?
Yes, sir.
Can you see the screen?
Yes, sir.
Okay. So today, in the last class, we discussed regarding the different data models which are normally used in a GIS. That includes mostly the raster and the vector data model. Okay, where the raster data model, it consists of grids and then individual pixels, where one pixel is a representation of an average value of a certain area of the ground. It may be elevation, it may be reflected energy, it may be emitted energy, it may be rainfall, it may be wind speed, whatever you can think of. So if you represent it in terms of grids, it will be raster data model. On the other hand, if we represent using points, lines, and polygons, that will be the vector data model. So in case of points, we can store the locational information. In case of lines, we can store uh, the length, the direction, and then the side, this kind of information. And in case of a polygon, we can store the area, uh, this related information. So mostly these three kinds of different vector models are enough to meet our demands of the vector data. Today, further, I will just show you how actually using some software we can see some of these raster data models. And these raster data models are mostly the satellite images. Okay, so are you ready? Hello, are you ready?
Yes, sir.
Good. Please pay attention to what I'm going to show. We are entering this application site of
Okay,
remote
sir.
sensing, mostly for disaster management now. So, as I said, that the oldest satellite data which are normally available for public domain is Landsat. Landsat was launched in 1972, and from uh, 1972, this data has been archived and it is distributed for civilian purpose. I don't know if you have internet with you, you can go with me, otherwise I'll just see the video. Maybe you can do it later. So in order to look for the data, I would like to explore one site known as ART Explorer. Sorry, ART Explorer. Can you see this in Google? ART Explorer. So go to ART Explorer site. And in the ART Explorer site, you have to create your login and password and your basically your own credentials. So for that, you can go to the login page and then sign in. If you have not created a new account, first you have to create a new account. Create a new account. Then once you create a new account, you'll have to give one email where you have to activate uh, the sign in page. So hopefully I have one account already. Let me check. I can sign in. Hmm. Anyway, so this part I can show you a little bit later, but let us straight go to the to images which I have already downloaded. Okay, so once you log in, you can search that website. I can show that in the next class, and then you can download the satellite image like this. So these are the three satellite images which have been already downloaded. These are from Landsat. Okay. So if you download these satellite images, it comes in bands. So here you see this is B10. That means this is band number 1. Can you see this? B20. This means band number
Yes,
2.
sir.
B30, band number 3. So from band number 1 to band number 3, if I can show you my presentation here. See this, Landsat 8. So this is again a Landsat satellite. So band number 1, this is also known as the blue band in case of Landsat 7. So wait, I can show you here in Google. Landsat bands. Okay, so here we see Landsat 7 ETM plus. ETM plus means Enhanced Thematic Mapper plus. So these are the spectral resolutions or the bands. So for Landsat 7, band number 1. So if I go to this downloaded image, this is my band number 1, B10. This is band number 1. So band number 1, it has a spatial resolution of 30 meter by 30 meter, and it has a spectral resolution of 0.441 to 0.514 micrometer. That is the size of the wavelength. So this wavelength normally corresponds to the blue color. So this is named as the blue band. Again, band number 2, the spectral range is from 0.519 to 0.601. So this normally corresponds to our green color. That is why this is named as the green band. So band 1, band 2, band 3. These are the blue, green, and red bands. So in our case, this is my band number 1. This is the blue band. Band number 2. This is the green band. Band number 3. This is the red band. Okay, or band number 4. So what is band number 4? Band number 4 is NIR. NIR means near infrared band. So normally, if you look at the spectral wavelength range for band number 4, it is 0.772 to 0.898 micrometer. So that is beyond our capability to see with a naked eye. Okay, that is why we do not see near infrared information with our naked eye. But in the satellite sensor, the sensor is designed to capture this information. Again, the satellite is also designed to capture information which is beyond band number 4, 1.1547 to 1.749. This is short wave infrared. Again, band number 6 is thermal infrared. So you can have a lot of bands which can be designed in order to capture information in successive ranges or wavelengths. Okay, so for Landsat 7, we have got around 1, 2, 3, 4, 5, 6, 7, 8, 8 number bands. If you want to see the metadata, so what is the metadata? Metadata means the data regarding the data. That means additional information of these bands. There is one file which is also a text file, MTL, which can be downloaded together. Next class we will see how to download this thing. Then you can open it using some text reader. Okay, I'm using WordPad here. So you see, so the metadata says this is Landsat 7, you see. So the satellite's name is Landsat 7. Then the sensor as a whole, it is named as ETM Plus or Enhanced Thematic Mapper Plus. Why it is called ETM Plus? There is a story. Earlier in the Landsat versions, there was no thematic mapper. That means there was no thermal band. From Landsat 5 onwards, it was introduced, and then in Landsat 7, it was further enhanced. That was why it is called Enhanced Thematic Mapper. Then the acquisition date. That means the date at which this image was captured. So the image was captured during 2010, 6 November. So we get the image of 6 November of 2010. Okay, so this is also regarding the time of the capture of the data. So further information, you get it here. This is the row number and then the column number of the grids. Forget about these other information. These are not really required for your purpose. So you see band number 1, band number 2, 3, 4, 5, 6. 6, that means thermal bands has got 2 bands, 6.1 and 6.2, then 7 and 8. Okay. Again, if I go further down, I will see some other relevant information. Okay, it says grid cell size of the panchromatic band. Panchromatic band is black and white band. It is 15 meter by 15 meter. Grid cell size of the thematic band, that means the thermal band, is 60 meter by 60 meter. So earlier it was 120 meter by 120 meter. Now in ETM plus, this resolution is reduced from 120 to 60. That is why it is called enhanced thematic mapper. Then other bands, they have got a pixel resolution of 30 meter by 30 meter. This all we will see today. Okay. So next you see the zone number UTM. That means Universal Transverse Marker. So as I said, this is from a place where the zone number is corresponding to UTM 46 North. That is somewhere in the region of Northeast India. So for our purpose, this would be a familiar satellite. Otherwise, the datum is WGS 1984. This thing we will learn later, and then resampling techniques and other things are shown here. But anyway, so these are all band number 1 up to band number 6, 7, 8. These are the bands of Landsat 7 that is being acquired from a date of 11 6 September, 6 November 2010. That was the date of acquisition. So let us open this image. In order to open the image, I am going to use the software known as NV 4.7. NV is not an open source software. So for your case, I will suggest that we use some open source software so that we don't have a license issue. Okay, so for that, probably we can use QGIS, that is known as Quantum GIS. So if you go to the website and type QGIS, that is for the next class anyway. You can go to download QGIS, and then in the download page, let it open. We have this QGIS. So we will go to the standalone installer. Okay. Uh, okay, so for standalone installer, depending on your processor type, either if it is a 32-bit machine or if it is a 64-bit machine, you will have to download one of these two installer files, and then you can install it in your own machine. So I suggest you please do this. So I'm going to share you the link here in the chat box. Just a moment. Let me open the WhatsApp. I can even share this link here. So this is the link where uh, you can download this software. Okay, so please install QGIS, the standalone version, depending on your processor type. If your laptop is a 64-bit machine or if it is a 32-bit machine, you have to install one of these two. How will you check? It is very easy. If you go to my computer or this PC, just go to check in the properties. Then you see system type. My machine is an old machine that is 32-bit operating system. Okay, so in my case, I am going to download this 32-bit installer file. Do you understand? Yes or no?
Sir.
Yeah,
Yes,
good.
sir.
Good. Okay, so for today's case, I'm going to use another software which is known as NV 4.7. NV stands for Environment for Visualization. This is a very powerful software in order to see the remote sensing satellite images. So, okay, so my satellite image is already downloaded and I have actually stored it here. Now, I'm going to open these individual bands. I go to that particular file. Okay, so this is my band number 1, my band number 2, band number 3, band number 4. Band number 1 means blue band, band number 2 is green band number 3 is red, and then band number 4 is near infrared band. Okay, so for the time being, I'm just going to load the 4 bands. All the information that has been captured using these 4 sensors and open. Okay, so you see there are two ways how I can open this image or display this image. Either I can open it using a grayscale image, or I can create a color composite, that is RGB, red, green, blue color composite. So for first case, let us try to open band by band. So let me open as a grayscale image. So for band number one information, I click here and then click grayscale and then load band. Okay, and you see it on the screen. This is a satellite image.
Yes, sir.
See, so this is a satellite image, particularly of the blue band. So let me enhance this image. You later know what is enhancement. Hmm. Okay, so as I said, this is a gridded information or raster information. There are three windows as you can see. So this is known as the scroll window, but this is actually software specific. Okay, so all the softwares you don't get to see all the three windows because I'm using NV. That is why it is like this. So this is the overall image, the small window, or known as the scroll window. So there is a red box. I don't know if you can see this red box. So whatever information is within the red box is shown in this window. Okay. And then there is again one more red box. This information is being shown in this smaller window. This is known as the zoom window. So I can zoom on and zoom on and zoom on into a particular portion of the image. As you can see here, this is my original image. I am going a little bit farther north. Okay, this is the box, and then within this box, whatever information is there, it is shown in the zoom window here. So I further zoom in and zoom in and zoom in onto a small window here, as you can see. So can you see these things clearly now? This is my, on the left hand side, scroll. That contains the whole image. The whole image has a size of 180 kilometer wide, width, and 180 kilometer length or long. This is known as the SWAT. And then within the smaller box, this red box, this information is this band number one, this window. Okay, and then within this small window, there is even a smaller red window. You can see that information is here in this zoom window. Okay, so this is the zoom window. Things should be clear once you practically do these things by yourself. Let me take this out. Okay. Okay. So in the zoom window, I am trying to show you the pixels, individual pixels. Can you see the square boxes here?
Yes, sir.
Yeah, right? So these square
Yeah, yes.
boxes are known as pixels, like the one that I have shown you here. You see the zebra? So this part of the zebra is zoomed here, and then further it is shown here. So this X and Y, this is the pixel. So in this case, we have the pixel, this smaller boxes of regular size and shapes. These are known as the pixels. So uh, these are these represent an area of 30 meter by 30 meter on the ground. That is the spatial resolution for this particular satellite or for this particular band of the satellite. So we know that this is band number 1. As I showed you here, this is band number 1. Band number 1, it has got a 30-meter resolution. This is the blue band, okay? This is the spatial resolution. So let us check this pixel. So if I right click here and then I go to the cursor location value, you see, can you see the cursor? That how will I say? This cross sign on the screen. Can you? Yeah, yes or no? Yeah, so you can see the cursor, right? So as long as the cursor is within one box, I get this information on the smaller screen. In the smaller screen, it is shown that R is, you see, can you see? Can you read? R 117, Z 117, B 117. That means we are only opening one band, okay? Where all these values are supposed to be 117. That these are known as the digital numbers. So these digital numbers are a representation of the amount of energy that is either being reflected or emitted or scattered from a area of 30-meter wide and 30-meter long on the ground. Okay. So within this 30-meter by 30-meter area or 900 square meter area, these values will not change. You see, if I go within the box, these values will not change. These values will not change. Because why? Because these are an average value. So even there may be some differences within 30-meter by 30-meter. The satellite sensor, it does not capture that variation. Okay, so as I said, the pixel is the element of, of this information storage. So if I use Landsat image, and if I want to get information maybe around 10-meter by 10-meter size, I will probably miss that information. I do not see the variation of the subpixel level uh, beyond 30-meter. So the moment I cross from one point to another, okay, so other things which are shown here, this is UTM, that means the projection which is being used to show this data on the computer screen, or the locational information that is being stored is latitude and longitude. So you can see 25 degree, 52 minute, 30.47 second north. That is the latitude, and then the longitude is 90 degree 43 minute 1.24 second east. So this is the locational information of the, the, the crosshair right now. So if I change it, these values will change. But once it crosses from one pixel to another. So just see. Now you see, these values have changed. Now you see, again it has changed. But within the pixel, these values, they don't change. You see? You see? 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 So the last information known as data. Data is the average value of reflection or energy that is being emitted or either radiated or reflected from that particular area of the ground. So this absolute level of energy is being scaled according to the radiometric scale of this satellite image. As I said, if I am using a scale of 8-bit to store this information, I have a range of 0 to 255, because 8-bit is 2 to the power 8 is equal to 256 houses of grayness, where I can store this level of energy. So that means the darker the pixel, this data, the last data, this value will be smaller. If you see, this is a brighter pixel, right? So if I cross this pixel, this is 39. Earlier it was 43. That means from this area, there is a higher amount of energy that is being reflected. That is why it is shown in a brighter scale, which is also known as the digital number. So, if I go to another area, now this level of reflection or the energy which is being emitted is a little bit less. Okay? Or is it very difficult?
Yes.
Yes or no? Are you getting?
Yes, sir. A little bit, but there are some many problems also because this is our first time, sir, like these topics.
Okay. So actually, the the best way was if I was able to just put you in front of the computer. That would have been the best way. But anyway, till
Yes, sir.
the situation is over, we'll have to manage things like this.
Yes, sir.
Okay, for the time being, just don't worry even if you're not getting it too much because we are onto the application side. So, as I said, uh, this is one image which is actually being opened in the grayscale, but I can open the image using the RGB or the red, the green, and the blue gun of this computer screen. You know, this computer screen, it has got three guns: RGB, that is the red gun, the green gun, and the blue gun. So, using this computer screen to project these different bands, I can create different color composites. So, as I told once in the class that there are two ways how we can use these composites. One is known as the TCC, the other one is known as the FCC. The TCC is the true color composite. So let us try to display this information as a true color composite. So what is a true color composite? Okay, so here I have the computer. Okay, in the computer I have got three guns: my red, my green, and then my blue. So these are the color guns. Okay, COLOUR, color gun.
Okay, sir.
GUN, color guns. So using these three color guns, we can see different colors on the computer screen. So in my case, the satellite image, I have got band number 1, band number 2, band number 3, and band number 4. So what is band number 1? My band number 1 is the blue gun. Band number 2, band number 2 is the green gun. Band number 2 is the green information. Band number 1 is the blue information. Band number 3 is the red information. And band number 4 is the near infrared information, which I do not normally see with my naked eye. So if I want to display this information as a color composite, and if I do it in such a way that this blue information I project onto the blue gun, this green information I project into the green gun, and then this red information I project into the red gun, I can create a true color composite, TCC. So that means as if I am sitting on the top of the satellite and then I am just looking down, right? So this blue information which has been captured by the sensor, I am projecting it into the blue color gun of my computer screen. The green information or the green band information, I am projecting it into the green color gun. And then the red information, I am projecting it into the red color gun. So I can create a color composite, which is known as a true color composite. That means as if I am sitting on the top of the satellite and just looking down. So let us see, which is my, okay, so is R means this computer or the software is asking, which is your band number 3 or red information. In case this is my band number 3, now it is asking where is my green band. So my green band is this band number 2. I click here. Then it is asking where is the blue band. My blue band is band number 1, this one. Then I load the RGB. Then you see what happens. See? What do you see now? You see the same image, right? But now in color. And not only in color, this is known as true color composite. As if you were sitting 700 kilometers above this art and then you were looking down.
Yes, sir.
Exciting?
Yes, sir.
Hmm. Okay. So, can you guess which area this is actually? Oh, by the way, I have to go to I have to go to another place at 10 o'clock. So for today, probably I'm going to close it right now. Anyway, so let us see and enjoy this thing. I'll share you the video. This is actually the Brahmaputra River. You can see the different tributaries in the river as well as the braided pattern of the river. Anyway, we can discuss this thing later. And then you can see the
Yes, sir.
various tributaries on the northern bank of the river. This is Arunachal Pradesh. From Arunachal Pradesh, these smaller tributaries are coming. So I'm talking about these things, okay? And then it is falling into the bigger river. And then the brighter spots in the river, these are the nothing but the sand or the barren sand. Okay? Okay, so let me let me take you to the closing part of this class right now. But before that, I'd like to ask you for your attendance. I have to go to another place with Mrs. Sir today at 10 o'clock. Just a moment. Uh, so by that time, you please give your attendances and then maybe tomorrow we will have a larger time to discuss about these things.
Sir.
Now we are actually entering the subject. So we are going to analyze these things, especially during the time when we have a flooding or maybe during the time when there is an earthquake that has happened, how you can do efficient decision making. Okay, I'm sharing this one. You please give your attendances here itself, okay?
Sir.
Okay, so I'm closing the class, stopping for time being, and then see you tomorrow. Okay?
Yes, sir. Thank you, sir.
Okay, yes.
Okay, sir. Thank you, sir.
Oh brother, why are you so class is just this question.